right, so this week we're going to be taking a look at section 6.1. Okay, we'll split it into 3 days. Part 1 will be today, part 2 will be Tuesday, part 3 will be Wednesday, and then Thursday, that will just be a review day for the test on Friday. Okay, so let's start out right away with a definition. Okay, we're going to define what's called a monomial. Monomial. Now, when you see the prefix mono, does anybody know what number that prefix is connected with? Mono?
Many.
So poly means many.
Oh,
like,
singular.
Yeah, like a singular thing, mono, right? Something you might not know, like a monocle. Like it's like one, like lens people used to wear to see things, I guess. What else begins with mono? Monochromatic. If you have something monochromatic, it basically means it's like one color. It's all one color, monochromatic. So mono generally is associated with the number 1. Yeah, were you gonna say something?
Like it was like there's like monoculars is 2 lenses and like
Binoculars? Binoculars? Yeah.
yes.
Yes. Binoculars.
Yeah, monocular is 1 and binoculars is 2.
Binoculars are 2. Yep. We'll talk about binomials maybe in a little bit. We'll see. Okay. But you guys have most of this written. But that's the key word right there. In algebra, we talk about a monomial. It's an algebraic expression that has, let's see what a monomial can have. It can have a constant. Okay, remember a constant is like a number. 2, 5. Okay, I'll give you some examples. 2, 5, 3 halves, negative 8.7. Those are all examples of constants. Okay. Variables. Somebody give me an example of a variable.
6.
What?
6.
6 would be a constant.
S.
Yeah, I could do S. My S's look like 5, so I'm just going to not write S because I don't make them well.
A.
Yeah, A. My A doesn't look like a number. So A.
G.
G or X. Okay, any of those are variables. Or it can be the product of a constant and a variable. Can somebody give me a constant and a variable multiplied together?
Isn't it like 5A?
Yeah, 5A, 3X, 2Y, anything like that. 4X cubed. Okay, that's definitely a monomial. These are all examples of monomials. So a monomial can have a number in it, it can have a letter in it, or it can have a number and a letter multiplied together. What you can't have in a monomial is this. You cannot have a plus sign. You also can't have a minus sign. Whenever you put a plus or a minus sign in, that separates it into more than one term. Now you have one here, and you have one here. That's called a binomial, because now there's two things separated with a plus or minus sign. Okay, so just no plus or minus signs in a monomial. How about something like this? 3x, y. Is that a monomial?
No,
Why not?
because there's multiple variables.
Well, is it okay to have more than one variable?
No.
So the product of a constant and one or more. You can have one or you can have more than one variable. Because that's what the definition is. It's the product of a constant in this case and one or more variables. In this case, there's 2. So yes, that is a monomial. That's fine. Remember, it just can't have a plus or a minus sign. How about something like 5x squared? Is that a monomial?
Yes.
Yes, it fits the definition of being the product of a constant. What's the constant in that case?
5.
5. And one or more variables. What's the variable in this case? Oh, Molly, what's the variable in this case?
No, Y.
No, not y.
X.
X. How about Marie? What if I had 3 plus 2y? Is that a monomial?
No.
No. Cannot have a plus sign in there. That is not a monomial. Eli, how about 4 times x, y squared?
Is that a variable?
Well, my question is it a monomial?
Yes, it is.
Yes, it is. It's the product of a constant, and in this case, one or more variables, an x and a y. So yeah, that's a monomial. How about 2x plus y minus 5? Lily, what do you think? Is that a monomial?
No.
No, because it has pluses and minus signs. This is actually a trinomial. There's 3 different things separated by plus and minus signs. How about 4? Is that a monomial?
Yes.
Yeah. A monomial can be just a single number by itself. Absolutely. How about q? Is that a monomial?
Mm-hmm.
Yes. Because a monomial can be just a variable all by itself. So it can either be a number by itself, a letter by itself, or numbers and letters multiplied together, but no plus or minus signs. Okay? So these are not monomials. Okay, so let's look at this. And we didn't use these words earlier when we described something. But let's say we have something like that. What do you call the 8 in that expression I wrote in red? The 8 is the what? Is that number written at the same level as the 3?
No.
No. So is it higher than the 3 or lower? Higher. So what do you call numbers that you write higher? Anybody know in math what we call those numbers? Well, how would you pronounce that?
Exponent.
Yeah, exponent. That's 3 raised to the 8th power. So the 8 is called the exponent. And does anybody know what you call the number that's down lower?
Base.
The base. Yep, exactly. Okay, so the exponent is a number that's up higher. So you guys need to write, you have the 2 lines, you just need to write those 2 things in. The exponent is a number that's up higher, and the base is what's below. Now the base could be a letter or it could be a number. Okay. In what's written in red, what's the base?
The 3.
The 3, yep. Now, look at what I just put a box around, x squared. What's the exponent inside that box?
2.
2. And what's the base?
X.
X. So in this case, the base was a letter. For the one in red, the base was a number. Okay? The base can be a number or a letter. It can be either one. But for what we're doing today, the exponent will always be a number. Okay? Could be a decimal, right? You definitely could have something like x to the 3.1. You could. That's still an exponent. Okay. Any questions on which one is the base and which one is the exponent? All right, so now we've got 3 rules here. I don't know if we're going to do all 3 right away. No. We'll probably do one of the rules and then I'll show you an example. Yeah. And then we'll do another rule, and then we'll do some other examples. So let's look at the first rule. It says to multiply or divide monomials. Okay, first thing we're going to look at is multiply. I'm not sure we're going to get to divide today. We will maybe tomorrow. Okay. So first of all, anytime you want to multiply or divide monomials, you should put this on the line that's right below that. The bases have to be the same. Okay, so somebody give me a letter that I could use as a base. A. So I'm going to take a to the third, and I'm going to multiply by a to the fourth. That I can do. I can combine those, I'm going to show you in a second, but those can be combined because they have the same base. Now, somebody give me another base.
3.
3? Let's stick with letters, just so, even though the base could be a number.
Z.
Yeah, let's just stick with letters. So let's say a to the fourth times z to the fifth. Those cannot be combined together. It's like these are not like terms. In order to combine them, the bases have to be the same. So any question on what I mean by the bases being the same? So let's try the one that we just wrote down. Okay, a to the third times a to the fourth. So this part, you guys can just read this. You don't have to write this part down because there's not really enough space to write it. But a to the third and a to the fourth have the same base. What's the base in a to the third and a to the fourth?
A.
Yeah, the base is a. But the exponents are different. That's fine. Different exponents, that's not a problem at all. Let's write this out and see if we can figure out what a to the third times a to the fourth is. Okay, so let's write it out. Okay, let's start with a to the third. Can somebody tell me what does that mean if somebody didn't understand this exponent of a 3? I'm going to multiply a together 3 times. Okay, that's what that part means. Then we have another dot. And then what about a to the fourth? Yeah, we're going to multiply the a together 4 times. Now, let's put that all together. A times a times a times a times a times a times a. When I combine that all together, let's start with the base. What do you think is going to go in that box?
A.
A. Yep, it's going to be an A. And what do you think the exponent will be?
7.
Yep, it's going to be a 7. If you look at the original problem, what were the 2 original exponents we started with?
3 and 4.
We started with a 3 and a 4. How can you get a 7 from a 3 and a 4 without writing it all out like that?
Adding.
Add them, exactly. And that's the rule when you want to multiply 2 monomials with the same base. You take the 2 exponents and you add them up. And you take the base and you copy down exactly what it was originally. Yep, that's the rule. So let's write that down. So we just did that. All right, so to multiply monomials, let me see, where did I put that to this? Okay, yeah, so let me let you guys copy this down. To multiply monomials, try to fit all this on those first 2 lines. So notice the first thing I say right away, with the same base. If they don't have the same base, you can't do anything. Okay, so to multiply monomials with the same base, take your exponents and add them up. and keep the base exactly the same that it was. If it was a, keep it as a. If it was x, keep it as x. If the base was a 5, keep it as a 5. So let's say we had something like this. 4 to the 6th times 4 to the 10th. Now, we could, again, you guys just watch me do this. Okay, we could write that all up. 4 times 4 times 4 times 4 times 4. But when these exponents start getting really big, we don't want to write it all out. It's going to take forever. So let's see if we can do this one with the rule. What does the rule say to do to the base?
Keep the same.
Keep it the same. What's the base in that problem?
4.
4. So we're going to keep the base the same. What does the rule say to do with the exponents? Add them. What are the two numbers we're going to add together?
2 and 6.
6 and 10. And what does that give you?
16.
Yep. That's the answer to that problem. And 4 to the 16th, that's a very big number. So generally, when you start to get numbers that have exponents that big, we don't usually write it out. Okay, here's what it would be if you tried to write that out. Okay, it's not super huge, but it's still pretty big number. All right, so let's try 1a. Now, if you ever see something that doesn't have an exponent, you can always put a 1, if that helps you. Okay, so if it confuses you because there's no exponent on that r, think of it like this. If something doesn't have an exponent, you can put a 1. Okay, so let's multiply these together. What's our base this time? R. And what do we do with the base?
But the same.
Keep it the same. Yep. So R is the base. What are my two exponents?
7 and 1.
And what do we do with the 7 and the 1?
Add 1.
Yep, we add them together. And that's it. That's your final answer. Okay, so you might be thinking, yeah, this is really easy, really basic. What starts to get confusing is when we combine multiple rules together. Okay, so when I start to give you problems like, let me show you kind of where we're going to be going. Okay, when we start to try to simplify something like that, part of it is what we did here. Okay, there is going to be a rule that we're going to have to add some exponents together, but we're also going to be multiplying some exponents. So when we start to put multiple rules together, then it becomes really important that we understand like each rule. Okay. But that's eventually the kind of stuff we're going to start looking at. Not all today. All right, so why don't you guys try, we'll do this with you, 1b. So c squared times d to the second. And remember the directions. Simplify if possible. Okay, so does anybody have any thoughts about example 1b?
Would you just like combine the base so it would just be like CD
You have to be careful on this one. Yep.
You can't combine them
You can't combine them. Why not?
because they're 2 different letters.
Because, yeah, the bases are different. So they said simplify if possible. It's not possible. So the only thing you could do is basically rewrite the original problem. That's the final answer. C squared times D squared. Nothing you can do. Okay. Any questions on why we couldn't do anything there? example 1C. Why don't you guys try 1C? And I think I have a 1D as well. Let's see if I can get them all on the board. All right, so why don't you guys see if you can try 1C, 1D, and 1E. Okay, see if you can simplify those three questions. Okay, once you get the answer, just call one of us over and we'll come check in and see what you got. Okay, let's look at the top one. X to the 4th, y to the 6th. What can we do with that one? Yeah, we can't do anything because the bases aren't the same. So when they give you something like that, just copy over the original problem, and that's all you can do. Okay, the next one. First question I have is, can you simplify it? Yes or no? Eli, what do you think?
Yes.
Yes? Why?
Because it's two different things. It's the same base.
It's the same base. So we're going to copy the base down. And what are we going to put for an exponent? 5. Yep, 2 plus 3. It's very important you add them. There is going to be a time when we multiply them, but it's not now. Okay, 2 plus 3 gives you 5. And Madeline, how about the bottom one? Is that one that can be simplified?
Yes. Yeah.
Yes, it is. What's the base going to be when you simplify it? M. And what's going to be the exponent?
16.
16. Perfect. Okay. Any questions on that? All right. So that's multiplying two monomials together that have the same base. You guys, everybody already have that rule? Okay. So now, let's take a look at, I kind of want to do the power thing next, so I'm kind of jumping around a little bit here. Yeah, so let's look at the next one. To raise, it's going to be a power to a power. Okay, so this one, this part we're just going to read it together, and we'll do an example, and then I'll give you the rule down below. You're going to write down what's under that gray part. All right, so this time I want to take a cubed and raise it to the 4th power. This is called a power to a power, because you're taking something that has an exponent and you're raising that whole thing to the 4th power. Okay? So let's see what happens. This says a cubed to the 4th power. So this number tells me I'm going to multiply what? 4 times. Tells me I'm going to multiply something 4 times. What's going to go in each of those parentheses?
8 third.
Right. You take whatever is below the exponent of 4, and you write it 4 times. So it's a cubed times a cubed times a cubed times a cubed. That's what this means. Any question on that first step? Now we can simplify this using the rule that I just taught you. What's the base on all of those? A. So we're going to have an A. And when you're multiplying things with the same base, what are you supposed to do with all those exponents? Add them all up. Yep. So what would you get for an exponent if you added all the 3's up?
12.
You'd get a 12. And that is the answer when you raise a to the 3rd to the 4th. Now, we don't want to have to write it out like that every time, especially if it was like to the 40th power. It's going to take forever to write all those down. So the exponent of my answer was a 12. What were the two numbers I started with as exponents? 4 and 3. Does anybody see how you can combine a 4 and a 3 and get a 12? And the hint, it's not adding them. You don't add them together.
Multiply them.
Yes, you multiply them. Multiplying exponents is what you do when you have a power raised, actually let me write it this way, to another power. So anyone think they know what that one would be? That's a to the 5th to the 10th.
A to the 50th.
Yep, exactly. That would be a to the 50th. So we definitely don't want to have to write that out because I'm not going to write a times a times a 50 times. That's a lot. Okay, but that would be a to the 50th. Okay, so this is the second rule on your sheets where it says to raise, and then you guys have to fill in what's underlined. To raise a power, and then copy the rest. To another power, you multiply the exponents, and you keep the base the same. So all the rules that we're learning this week for exponents, they're all pretty easy. It's just a matter of knowing which one to use. That's the part you have to figure out. Okay, so this is called a power to a power. Does everybody have that rule? Multiply the exponents and keep the base the same. All right, so let's try a few of those. So I'm going to come back to example 2. Okay, but I want you guys to flip it over on the back, and let's go to example 3. I just wanted to switch the order up a little bit. So let's try 3A. All right. First, can somebody just read to me what that says?
C to the power of 2 to the power of 5.
Yep. C to the power of 2 to the power of 5. Perfect. Okay. So Zach, can you say that again? You were starting to say, what's the base going to be?
So the base,
Yeah.
c times c squared
So C is the base, yeah. And what's going to be the calculation for the exponent?
to the power of 2 times to the power of 5.
So C to the 2 times 5.
Yeah.
And what does that come out to?
10, c to the power of 10.
Yeah. That's how you raise a power to a power. Multiply the two exponents together. Okay. Any questions on 3A? All right. Why don't you guys take like 30 seconds and then try 3B. And then we'll just check in with you guys, make sure you get it, and then we'll go over it together. Anyone think they could give me the final answer when you take y to the 3rd and raise it to the 10th?
Y 30.
Y what?
30.
Just be careful how you say it.
Y raised to the 30th power.
Yep, you can say y to the 30th, or you can say y raised to the 30th. You just have to indicate that that 30 is up higher. Yep. Okay. So that's it, y to the 30th. Any question on that? Okay, so now we're going to go and do, you can still keep your worksheet on the same side. We're going to do example 2. Okay. So it says, to simplify a product of monomials such as, and I think you guys already have these examples written down, right? You guys, okay. What we want to do is group it together so that the like terms are next to each other. Look at the c squared. What do you think that can be combined with in the next parenthesis?
The C.
Yep, can be combined with the c. What do you think the d can be combined with?
D to the power of 3.
D to the power of 3. And what do you think the negative 3 can be combined with?
7.
With the 7. So we're going to multiply all these together, but what we're going to do is rewrite it like this. When something is multiplication, you can rewrite it in any order you want. So let's put the negative 3 and the 7 next to each other. Let's put the c squared and the c next to each other. And let's put the d and the d cubed next to each other. So we're just putting together the like terms. So on your guided notes, you want to write down what's underlined. Multiply together the like terms. And some people just do that in their head. They just look at it and write it. I'm writing it out so you guys can see it. Now, there's no exponent on this c. It's c to the squared and a c. What number is always an exponent if you don't see it?
1.
Yep. So this has a 1 on it. And that also has a 1. Okay, let's try this one and see what we get. What's negative 3 times positive 7?
Negative 21.
Okay, negative 21. What's c to the second times c to the first?
C3
Yep, c,
to the power of 3.
yep, c to the third. And what about d to the first times d to the third?
D to the 4.
Yep, d to the fourth. That's the answer. Why can't we put the c and the d together and write something with a power of 7? Yeah, they're different letters. They're not the same base. So that's all you can do. Any question on that? All right, so let's try example 2a and 2b. So we'll do 2a together, then I'll have you guys try 2b. All right, so let's just fill in a few things in case we're not sure what's what. What's the exponent on this first y, even though it's not written?
1.
That's a 1. And what number is in front of this x, even though it's not written?
1.
Yep, there's always a 1 there. Okay, so if you want to write those two things in because it helps you to think about it, you can. Oh, and what exponent is on the x, even though it's not written?
1.
Yeah, that's a 1 as well. Okay. So let's start with the negative 5. Is there anything I can multiply negative 5 by? Because negative 5 is a constant. Is there any constant in the other set of parentheses?
Negative 1.
Yep. The negative 5 and the negative 1 are both constants. Therefore, they are like terms, and they can be multiplied together. All right. Let's go to the x squared. Is there anything that the x squared can be combined with in the next set of parentheses?
Yes.
Yeah, what is it?
The x1.
Yep, the x to the first. Okay, so I'm just going to kind of cross out what we've taken care of. Took care of the negative 5 and the negative 1. We took care of the x squared and the x. What's the next thing in the first set of parentheses?
Y.
Y. is there something I can multiply in the next set of parentheses to combine it with the y?
3. The Z3.
No. Why can't I combine y with z to the third?
She said a different letter.
She said you can or you can't?
I meant to say you can't.
Yeah, you can't. Yeah, because they're different letters. So there's nothing we can combine with the y, so we're done with that. Is there anything else we need to write down?
Or the Z3.
Yeah, the z to the third, but there's nothing we can combine it with. So we're just going to put it by itself off to the end. Okay, so now let's combine what we can. What's -5 times -1?
5.
Yep, perfect, 5. What's x to the second times x to the first?
Next to the third.
X to the third. And then what do we do with the y?
Combine them. Like actually like the end.
Yeah, we're just going to put it on the end. There's nothing you can combine it with, so it's just going to be a y. And then what about the z cubed?
Yeah, just by itself.
We're just going to put that right on the end because there's nothing we can combine it with. And that's it. That's your final answer. Now, technically, it doesn't matter what order you write this in. Like if you wrote x cubed, z cubed, y, and then a 5, it's okay. I would say generally they put the answer in alphabetical order, but you wouldn't get it wrong if you did. Okay? All right. You know what? Let's do this one together, and then I'll let you guys try one of the example 4s by yourself. Start with the 3. Anything that I can multiply with the 3 from the next set of parentheses.
The -2.
Yep, the -2. Perfect. Okay, so took care of that. Let's go to the a to the 5th. Anything I can multiply with the a to the 5th from the next set of parentheses?
No.
Nope, because it doesn't have an a. So we're done with that. Let's go to the b to the 4th. Anything I can multiply with that one?
No, wait, no. The B to the 3rd.
B to the 3rd. Yep. Okay, so took care of that. Took care of that. And then the next thing we have is a C. Is there anything I can multiply with the C in the next set of parentheses?
The C8.
Yep, C to the 8th. Okay, let's do that out. Eli, what's 3 times -2?
-6.
Yep, so -6. Marie, what's going to be the next thing after the -6?
You break down the a to the 5th power.
Yeah, we're going to just bring down that a to the 5th. There's nothing I can combine it with. What's going to come after the a to the 5th?
B to the 7th.
B to the 7th. Okay. And Zach, what's going to come after the b to the 7th?
C of B. No.
Maybe C to the 9th.
C to the 9th. Right? Because that C
Is a 1.
has an invisible 1, and 1 plus 8 gives us 9. Yep. All right. Any question on that? All right. Let's look at our last example. Okay, so as always, I'm going to show you an example first, and then I'm going to give you guys the rule. We'll write the rule back on the front. Just give me a second before we get to it, and let's see what happens. This is called a product to a power. Okay? So we had power to a power. This is a product to a power. How do we know it's a product? Inside the parentheses, it's 2 times x. That's a product. And that whole thing is being raised to the third power. Okay, so if we're raising something to the third power, means you're multiplying something together 3 times. What would be in each of those parentheses if you write that out?
2x.
Yep. We'd have 2x, 2x, 2x. Now let's do what we just did on the last couple problems. The first one has a 2. Is there anything I can combine that with in the next set of parentheses?
The 2.
The 2. Is there anything I can combine that with in the next set of parentheses?
2.
Another 2. Yep. Okay, so took care of the 2's. All right, now we have an x. Is there anything I can combine that with in the next parenthesis?
The x.
Yep, the x. And anything I can combine that with in the third set of parentheses?
The x.
The x again. So now, look at what you have here. 2 times 2 times 2. Okay, I don't want the answer, but I want to know, is there a shorter way you can write 2 times 2 times 2?
Yeah.
What's the shorter way? But not the final answer.
2 to the third.
Right, that's 2 to the third power. And what's a shorter way of writing x times x times x?
X to the third.
X to the third. Okay. Look at what you had here, and look at what you had here. This one, it's kind of like distributive property. Kind of. It's not exactly the same thing. You're distributing that number to the exponent. Okay. Each of them had an exponent of 1. 3 times 1 gives me 3. 3 times 1 again gives me another 3. So that's basically the rule when you raise a product to a power. It's like you distribute that exponent to each power. So what if I had 3x to the 4th? And I wanted to square that. What's the exponent on the 3 right now?
1.
It's a 1. And we're going to distribute that 2 to each number in the exponent. So instead of 3 to the 1st, what would it become?
3 to the third.
3 to the... It's like you're distributing that 2 like you're multiplying it. Anybody think they see what it would be?
Wait, what was the question?
What would be the new exponent on the 3? 2. And it's going to be x to the, what's going to be the new exponent on the x? 8. Yep. So it would be 3 to the 2nd, x to the 8th. And you can do 3 to the 2nd if you want to write 9, because it's small enough we could write it out. All right. So on that last rule where it says to raise a product to a power, you want to write down everything that's underlined. Raise each factor to the power.
This is the rule.
Yep, this is the rule, and this is back on the front. And then we'll try a couple examples. Okay, so to raise a product to a power, we're going to raise each factor to the power. All right, does everybody have the rule written down? try. Start with this one. Okay. Negative 4c to the third power. What are the exponents on the negative 4 and the c right now? Because they're not written.
1.
Yep, they're both ones. So the directions say raise each factor to the power. Here's the first factor, negative 4. What's the power on the outside that we're going to raise this to?
3.
3. So we're going to start with that. All right. Now, that's my second factor, c to the first. What's the power on the outside that we're going to raise that one to? 3. Yep. So you raise each one of these things on the inside to the number on the outside. Okay, so now we're going to have negative 4. This is a power to a power. What do we do with these two numbers when you raise a power to a power? Yep, how do you combine them though? You multiply them. Yep. What's 1 times 3? So that's going to be 3. And now we have the same thing again. C to the first to the third. Power to a power. What do we do with the 1 and the 3?
Multiply.
Multiply them. So it's going to be c to the third. Now there's not much we can do with c to the third. That's done. But now negative 4 times negative 4 times negative 4. Let's do that on the calculator. That's not that big. That's when I would probably ask you to just write out the answer. So negative 4 cubed is negative 64. That's the final answer. Okay. Any question on that one? All right, let's try. I think just for the sake of time, we'll do the last couple together. Okay, what's the exponent on the x?
1.
Yeah, it's a 1. There's nothing there. So now you're going to raise each of those factors to the power on the outside. Let's start with the negative x. What are we going to raise the negative x to? To what? Yep, to the 4th power. What's the other factor that's inside the parentheses?
Y to the power of 2.
Y to the power of 2. And we're going to raise that to what power?
4.
Yeah. It's like you're distributing that 4 to each one of those. Okay. So now we're going to have negative x. And how do we combine the 1 and the 4? Because it's a power to a power.
Multiply.
Yep, multiply. What's 1 times 4?
4.
4. And now y to the 2nd to the 4th. How are we going to combine the 2 and the 4?
Multiply.
Multiply. What's 2 times 4?
8.
8. And now here, remember what this means. Negative x times negative x times negative x times negative x. What's a negative times a negative? So when you multiply those together, you get a positive. What's a negative times a negative? Positive. What's a positive times a positive?
Positive.
Positive. Whenever you raise a negative to an even, the negative cancels out. You don't need this negative anymore. Raising it to the 4th power makes it go away. If it was to the 5th power, no, the negative would stay. So that's the final answer, as simplified as you can get.
So Mr. Hager, if they left the negative sign on the X, would that be considered wrong? So it's negative X to the fourth?
Yeah, it wouldn't be fully simplified.
Okay.
Yeah. So anytime that you have a negative and this number is even, the negative is going to disappear. So we're not going to do example 4C, but can someone tell me, would the negative disappear on that one, or would it stay?
Disappear.
It would disappear. How about this one? Would it disappear or would it stay? That one, it would stay. So, yeah, there's nothing you could do with this one. All right, so the homework for tonight is the 6.1 Part 1 worksheet. Okay, and that is on Schoology.